Welcome to the 12th lecture of Linear Algebra. In the previous lecture, we had discussed about rank of matrices. Now we are going to elaborate the term rank of matrix. The rank of a matrix is the number of non-zero rows, that is number of pivots in the reduced row echelon form. Suppose the matrix is like this. So this matrix is converted to reduced row echelon form like this. We had discussed the reduced row echelon form in the previous lectures. So here we have three pivots, this one, and this two. Actually, this column does not contain any pivots. So here we are having three pivots. Rank is the number of non-zero rows or number of pivots. So rank of this A equal to 3. The rank of M by N matrix cannot be greater than N or M, where M is the number of rows and N is the number of columns. So rank of A is less than or equal to minimum of Mn. Since in one row we have only one pivot, this condition will satisfy. So we are having three pivots. So this red column and this blue column contain free variables. So how will you find the solution of this equation? Solution of the equation is Ax equal to 0, x1, x2, x3, x4, x5 equal to alpha 1 minus 2, 1, 0, 0, 0 plus alpha 2 into minus 9.50 minus 4 minus 0.51. Case 1, we are going to select alpha 1 equal to 1 and alpha 2 equal to 0. So then solution becomes, so this alpha 1 is 1. This term will become 0. So x1, x2, x3, x4, x5 equal to minus 2, 1, 0, 0, 0. So we will get matrix is like this, 1, 2, minus 1, 3 is the first column. So x1 into first column plus x2 into second column. Second column is 2, 4, minus 2, 6. Like that, we will get a matrix like this. So finally, we will get like this. Here, we can solve this equation and we will get x1 equal to minus 2, x2 equal to 1, x3 equal to 0, x4 equal to 0, and x5 equal to 0. From this, we will get minus 2c1, that is column 1, plus c2, all other terms are 0. So we will get an equation minus 2c1 plus c2, that is column 1 and column 2 are dependent. So in other words, we can write it as c2 equal to 2 into c1. Another case, so here we are going to select alpha 1 equal to 0 and alpha 2 equal to 1. So solution becomes, so next first term will get eliminated, we will get only the second term, minus 9.50 minus 4 minus 0.51. So from this, we will get these equations, x1 equal to minus 9.5, x2 equal to 0, x3 equal to minus 4, x4 equal to minus 0.5, x5 equal to 1. So from this, we can frame equations like this, minus 9.5 C1. So minus 4 into C3 minus 0.5 C4 plus C5 equal to 0. From this, we will get, we can write C5 as, this will be moved to the right hand side. So 9.5 C1. It becomes positive. Again, this becomes positive. So plus 4C3. This becomes positive. So plus 0.5 C4. C5. So this C5 depends on C1, C3 and C4. So we have three linearly independent columns and we will get two linearly dependent columns. So which are the linearly dependent columns? C2 equal to 2C1. So these are 2 and 5 are the linearly dependent columns. Rank of a matrix is the number of linearly independent rows or number of independent columns. So this is another definition for rank. So another definition, column space or C of A. That is a span of column vectors of A. And row space is defined as the span of row vectors of A. So again, rank is defined as the dimension of row space or column space of A. So dimension means the number of linearly independent rows. So another theorem is known as rank nullity theorem. So this is our matrix. Row reduced echelon form will be like this. So we will have three pivots. We are using the same example itself. So solution to this system is alpha 1 into minus 2, 1, 0, 0, 0 plus alpha 2 times minus 9.5, 0, minus 4, minus 0.5, 1. So what is the rank? Number of non-zero elements. So it will be number of pivots is 3. So rank is 3. So nullity is the dimension of null space. Null space is the solution set of Ax equal to 0. How many solution sets are possible? 2 solutions. So nullity equal to 2. null space is the solution set of the system. So the solution set of A of x, we have the dimension is 2 because we have two vectors, that is these are the two vectors which can generate any solutions of this set, and these two sets are linearly independent. And also we can see that the nullity equal to number of free variables. Which are the free variables? Non-pivot elements. So these are the pivot elements, these are non-pivot elements. Other three columns contains pivot element. So red column and blue column contain free variables. So number of free variables equal to 2, therefore nullity equal to 2. Nullity can be defined as the dimension of null space, or it is otherwise defined as the number of free variables. So number of free variables can be found by n minus r's, and r is the rows with the pivots. So rows with pivots is known as rank. So rank of A is denoted as r. So the rank nullity theorem states that rank of A plus nullity of A equal to n, where n is the number of columns. Find the rank of A. This matrix is this one. So after this, we are going to find out the reduced echelon form. We will get finally this matrix. So here number of non-pivot elements, number of pivot elements are 2. So rank of this one is 2. Again another question. So this is our A, 1, 2, 0, minus 1, 2, 6, minus 3, 1, 4, 4, 5. So here also, we are going to find the number of pivot elements from the reduced echelon form. So here we are having 3 pivots. So rank is 3. Rank in terms of determinants. So first we have to define a submatrix. Suppose A is any matrix of order m by n. Then a matrix formed by leaving some rows and columns from A is called submatrix of A. So submatrix of A can be found by leaving some rows or columns. So rank is defined as an m by n matrix A has rank r greater than or equal to 1 if and only if A has r by r submatrix with a non-zero determinant, whereas the determinant of every square submatrix with r plus 1 or more rows is 0. So first of all, rank is greater than or equal to 1 when if the submatrix with a non-zero determinant. If any submatrix have a determinant 0, then it means that rank is not greater than 1. So determinant of every square submatrix with r plus 1 or more rows is 0. In particular, if A is a square matrix, it has a rank n if and only if determinant of A not equal to 0. If determinant of A not equal to 0, then only we can find the rank. Rank of a 0 matrix is 0. This is very important. Then another question, A equal to 3, 1, 2, 6, 2, 4, 3, 1, 2. So determinant of this A is 0. Why? Because the first row and the last row are same. So all the 2 by 2 submatrices are having 0 determinant. Therefore, rank is 1. Another question, A equal to 1, 2, 3, 3, 4, 5, 4, 5, 6. So determinant of A is 0. Therefore, rank must be less than 3. So here number of rows is 3. So it must be less than 3. Also, here the determinant of one of the submatrix is not equal to 0. Therefore, rank equal to 2. Another question. This is our question. It is an identity matrix. Determinant of identity matrix is 1 actually. Therefore, rank is number of pivots. So it is equal to 3. So as a conclusion, rank of A can be found out by finding the number of pivots, then find the number of linearly independent rows. It can be equal to the dimension of C of A, or it is defined as the dimension of R of A, or rank can be defined in terms of determinants. So there are a lot of definition for finding the rank of a matrix. So it is very easy to find the rank of matrix using these formulas. Thank you.